talk is called Discrete Degrees, and there will be some discussion about physics and psychology in this evening, and less about God. God will appear a few times, but mostly I'm trying to establish an idea of what discrete degrees are, because as Swedenborg says, this is essential to understand the relation between spiritual, mental, and physical, and also between these things and the divine. So we want to look into, have some ideas of what discrete degrees are, and then I'll try to explain what I think discrete degrees are. Multiple degrees. Because I want to then use some of the ideas so far, and I want to, and later, next week, I want to show how you can use these ideas to show how God, for example, and creation are separate but interrelated. So this is the challenge. And all of these things, discrete degrees are separate, distinct, distinguishable, but they're connected, causally connected together. So the challenge is to have a sort of a scientific way of understanding how that works. And as I said, this idea comes from Swedenborg. But I've used this idea to go back to physics and trying to understand basic physics. Okay. And just as a flavor of how this can be used, I'm going to discuss different ways in which mind and matter can be related. We have mind and matter. In the first view, okay, that's supposed to be a shaded. We can have matter causes mind, which is sort of the physicalist view. We can have mind causes matter, which is like a new age, or we create our own reality kind of view. Then we have the idea of in which mind and matter are in parallel, but they don't cause each other directly. This comes from Leibniz's pre-established harmony, and it's still used in Swedenborgian circles when they think of things related by correspondences. But I want to advocate a view in which mind and matter interact. Descartes had them interacting. So there are causes in both directions, but not of the same kind. Okay? So if you look at the picture there are arrows going in each direction, but not the same kind of arrow. There's a causation from mind towards matter, but there's some kind of arrow going back. It's not the same kind of arrow, but it is an arrow. There are effects going in the backward direction.
So you understand that when Swedenborg talks about this idea of mind and matter interacting,
yeah,
he would say that on each distinct level there's an interaction on a horizontal.
Yes.
But that the levels are, I don't want to use a hierarchy, they're kind of like going from inward to outward.
Yeah, but they still
don't go backwards. They only interact on the horizontal.
I want to show that there must be some backward connection of some kind.
You're saying across the distinct levels.
Across the levels, there has to be some causal connection. If you say they don't interact, then you're going back to this number 3 here, in which mind and matter are like parallels. They just happen to behave in agreement with each other. So we need to understand how Swedenborg can be correct about causation only going from God down towards nature, but still there's some effect back from matter. So we'll come to that, okay? So in Swedenborg there are many discrete degrees, so I want to understand that. Now I'm going to have a couple of little simple physics experiments. Galileo had an experiment in which a ball was rolling down an inclined plane. So this is someone dressed up as Galileo in a museum in Italy. And we think of the gravitational force acting on this ball coming down the plane. So we're going to think of it just as a fixed force. And if we want to know what the effect of this gravitational force is on the object, we use Newton's second law, which is force F equals ma, force is mass times acceleration. And we're going to use it in this other way around. We're going to say that acceleration is the force divided by the mass. In other words, acceleration occurs as a result of the force acting on the mass. This is perfectly standard Newtonian physics. This is the way Newton interpreted Galileo's experiment. So I now want to say that force is a disposition, because it's a power or propensity. Force is a disposition to accelerate a mass if the mass is present. I mean, it might seem rather obvious, but forces don't accelerate if there's no mass. So the force can be there, but the acceleration only occurs if there's a certain circumstance or occasion of the mass being present to be accelerated. And so I want to summarize this by saying that in the presence of an inertial mass, the presence of inertial mass is the occasion for motion. So the ball being present means that the force can act on it and produce the effect. The force can't produce the effect directly without the mass being present. Forces don't produce acceleration if there's no particle to be accelerated. So you have to set up the experiment. There has to be something physical there for the force to act on. And so the principal cause, I'm going to say, is the force, but the occasional cause is the presence of the particle. So the occasional cause is the condition that has to be satisfied for the principal cause to operate. And now we can do this again. If we think of now an inclined plane with various slopes, you can think of going up and down a hill on a bicycle. It's sloping up on the left and sloping down on the right. And the force is going to vary according to the slope. If you've been on a bicycle, you know this very well. And the gravitational energy produces the force. As you go up the hill, you have to put in energy, which gets converted to gravitational energy. And at the top, you've got all the maximum gravitational energy. And when you come down, changes in the gravitational potential produce the force. So this is rather simple physics, Newtonian physics, but the force that we had on the previous transparency is produced by the gravitational energy. And it's produced according to the slope. In other words, the variation in the local conditions of the action. So we have a similar pattern to what we had in quantum mechanics. We have these 3 discrete degrees, or 2 stages of operation. On the left, we have the potential energy, which could be gravitational here. Newton's law of gravity tells us how that produces the force. Forces add, and they do things there. And Newton's second law tells us how the force produces the acceleration. So this is simple, so to speak, high school physics about how things behave in a gravitational field and how things are accelerated by forces. But even here, I argue, we have these discrete degrees or discrete subdegrees or whatever they are that should remind us of Swedenborg. They should remind us of how Swedenborg has discrete degrees because it's the same process going on. So again, we see 2 stages for the operation of propensities. That's a physics example of 3 discrete degrees with 2 stages of operation. Now I'm going to show an example from psychology, a rather simple example. We're going to talk about the deliberate control of hand movements, okay? And psychologists have investigated this. They have this complicated picture here, which the font is a bit small to read, but it starts off by, you first of all have an intention, one of your intentions to act. It's remote from the hand itself, so it's called distal or D. And then there's the monitoring. When I move my hand, I look at it to make sure it's going in the right place. So if I'm trying to find something that's moving. So this is proximal control of the hand, so detailed monitoring of the motion of the hand. And then this detailed monitoring of the hand then guides the operation of the muscles. So we have what the psychologists call cascading intentions. The initial intention produces a monitoring in detail, and then the monitoring in detail controls the actual operations of the muscles, and then it produces the movement. So we actually have 3 stages or 4 discrete degrees, because we have the initial intention, the proximal control, the motor control, and then the actual outcome. So that I'm arguing that this is a simple example from psychology of the operation of discrete degrees. And those people with the Swedenborg background can recognize some of the intention and understanding and action there in that set of 3 discrete degrees. Yes, Steve?
You would say how there's a communication coming back.
Yes.
So would the example of the correction be an example of the
yes.
bottom?
So if this picture here has some little arrows going back up on the right-hand side. You have to monitor your action. So vision, okay. To take a simple example from the Swedenborg, if our mind looks at nature, looks at a physical thing, there has to be input from the physical thing back into the mind through our eyes. So there has to be some way of getting feedback from the physical degree to the mental degree. Otherwise, when we look at things, we will never notice anything because our mind couldn't be affected by the physical. So it's clear there has to be some feedback in both directions. That should be obvious, except some people forget it. So what I want to say now is that, oops.
So if somebody is blind, how do they?
They still have a proprietary sense of motion. They have a very delicate hearing and sense of touch, which enables them to control things. They can write pencils, you know, they can do, other senses become more acute normally in that situation. I want to say that these examples, I've given now 4 examples of discrete degrees from, shall we say, normal science. We have the quantum mechanics, energy, propensity, actual selection, classical physics, potential energy, forces, acceleration, psychology of motor control. These are all examples of discrete degrees that are known by science already. And if we were to get a better understanding of Swedenborgian discrete degrees, then we should pay attention to what these discretes are, because we're going to learn something. And that's what I say. So we're not making a giant leap into Swedenborgian discrete degrees. We're going to learn from what science knows already. It's just a question of recognizing that these are discrete degrees, because it's not obvious that they are discrete degrees. So as I near the end, I will give a couple of slides of the sort of general principles. I'm going to summarize what I've learned from these examples and summarize them in a general way. I'm going to talk about A and B. I'm going to first of all talk about 2 discrete degrees with 1 stage of operation, which is that if we have just 2 discrete degrees, all of the previous examples were more complicated, but this is a simple example. So A generates B. A is up and it generates B. But the point is, in all those examples, which new B was generated by A, the selection of the new B is determined by the old B, okay? So if we go back to those examples let's see, which one should we choose? The ball rolling down the plane. The acceleration depends on the mass being present and where it's present and so on. Or when we go to quantum mechanics, the actual selection at a later time depends on what previous actual selections there were. And in quantum mechanics also, the wave function at a later time depends on what the initial wave function is. So there's a dependence, and I'm going to draw a picture of this to illustrate. And if you want to imagine it in your mind, you can think of A being our mind and B as physical effects. Those are B's there. Very pale. Or you can think of God and the world if you want to have some dramatic example. So in 2 degrees, we have A generates the successive events in the 2nd degree, but the choice of which events are selected depends on the previous B. So these black arrows are selection which guide the operation of these generation events. So this is, I want to claim, is the general way that Swedenborgian discrete degrees operate. There's always the twin processes of generation power coming down, but also the previous existence at the lower degree selects in which ways this power can operate. You could easily generate Markov chains like this, I agree. But I'm not saying it's random or not. I'm just saying that there is the better idea is causal networks. I don't know, but you can describe them using Markov chains. It's rather similar. And there are these twin processes of generation and selection, which is what I want you to remember for how how discrete degrees operate. There are both generation and selection. If you just have generation, then the outer layer is produced, but it never has any effect on what happens in the future. It's sort of like just an outside layer which is produced and then blown away. And if A was our mind and B was the physical nature, then we would never be able to observe what happened in the physical world because we would never get feedback from the physical world. So there has to be both. So there are processes going in both directions, but not the same kind of process. And I claim that these twin processes of generation and selection are, you can see them clearly in those examples that I gave earlier. In all of those examples, there were, if you looked into how it operates according to science, there were both generation processes and selection processes operating. And so I say that it would make sense also from Swedenborg's point of view that there are both generation and selection. However, if you just take these two layers like this, okay, generation is from the higher degree, it's the principal cause, and selection is from the lower degree, it's called occasional cause. And the general rule is the principal cause operates according to the occasional cause. That's sort of the influx, the law of influx that Swedenborg has.
So, it'd be like gravity would be the generation,
Yes.
and the slope of the angle would be the selection.
Yes, for example. So the effect of gravity depends on the slope of the object that is accelerated. We know that. And if the slope is flat, gravity doesn't have any effect. But if it's steep, it has a big effect. So the slope is not doing anything, but it's conditioning what the generative cause does. So now, if you just had these 2 degrees like that, then we have pure. If A was God and B was the world, we would have what's called pure occasionalism. Nicholas Malebranche, at the same time as Newton, had this what I call simplistic view in an attempt to understand the relation between God and the world. The trouble with this simplistic view is that every action is caused directly by God, okay? Every fish jumping out of the ocean is God jumping out of the ocean. Every action, every evil action, every good action we do is God acting immediately. Now, some people might be happy with that, but I don't think reality is that simple, because we saw even already that there are more than 2 degrees. So let's consider 3 discrete degrees. And we think of, if you want to picture it in your mind, as A is God producing mental operations which produce effects. Okay? So A generates the further existence of B, and B generates the further existence of C. But each new B is generated by the previous B, so we have a complicated network of generation coming down and selection sort of going sideways or very slightly up, so to speak, if you want to use a spatial metaphor for what's going on here. So, and then the time goes to the right. And so I summarize it by saying all generation is down and all selection is from below. And I claim that this is actually, even this triplet of discrete degrees gives a better understanding. It's no longer a pure occasionalism, okay? It's no longer God acting directly in the physical world. It's acting by means of an internal degree. And it's no longer a pure occasionalism because degree B, the middle degree, these things really exist. They are propensities for doing things, producing C's, and therefore they really exist as substances. The middle degree is a substance, but it's continually being produced by A, and it's continually producing the lower degree. And we say that B, the middle degree, filters the initial propensities of A to select and affect what the result is. And most interestingly, the first degree never changes. Okay, so that makes sense from the God point of view. God is the A at the top here that produces effects all the time, but never changes or never necessarily changes. So that point of view makes sense. And I'm going to add here that there's still questions of the relative importance of generation and selection. If generation was dominant and selection was minimal, then you have sort of this new age idea of we create our own reality. But if generation was very weak and selection was dominant, then we would have a materialistic view in which the lower degree only depends on the previous lower degree and nothing of influx from above. So this is a general framework in which you can discuss the relative importance of generation and selection. So the detailed science consists of seeing exactly what generation occurs and what selection occurs and how much freedom and room to maneuver there is at each stage. That's where the crunch is. Okay. So let's now begin to wind up. I've repeated this pattern of the 3 discrete degrees here. And in quantum physics, we have these energy, propensity, outcomes. And I can summarize it by saying that there's a principle of energy, there's a distribution of form, and then a final effect. And this is, I can claim, just like in the mind. In the mind, we have a desire, which is the initial motivation just in the mind. We have thinking, which is the intermediate step. Our desire thinks what to do, and then it acts. So I'm saying that desire is like substance and thinking is like form. And this also agrees with Swedenborg. And so what I'm saying, there are similar processes of generation and selection in the minds and in nature. So the same general philosophical principles are involved in both the discrete degrees in mind and the discrete degrees in nature. And each degree, I haven't actually justified this, each degree has its own being because it's its own substance. It has its own space because it has its own interaction propensities, and each is a substance, therefore it exists.
Do you mind if I ask you to, keeping this in mind, the 3 degrees, and go back to Malebranche's 2 degrees?
Yeah.
Malebranche was one of the philosophers Swedenborg read the most of. And is Malebranche of his 2 degrees, he's collapsing A and B for the energy dispositions?
Yes. Well, I mean, you can have a disposition which just produces effects immediately. Imagine the love of God immediately producing physical effects without thinking, so to speak, or without planning, without consideration before acting. You could conceive of the world being made that way.
His occasionalism was that the phenomena gave God the occasion for acting?
Yes.
Or vice versa? I guess that's...
No, phenomena gave God the occasion. So my deciding to move my hand was just the occasion for God moving my hand. So I'm using the word occasion in the same sense as that he used occasion. It's the same occasionalism.
Right. So he didn't actually see any causal relationship.
No, not if you look at his view.
Like Leibniz's in a way.
Yes.
These two.
No, Malebranche had God's power acting all the time.
Okay.
According to the occasion of our actions, this influencing God. So God looked at what we decide to do, if we, in fact, we could decide to do. That's another question, and then acting.
Okay.
So I think we're coming to an end here. I just want to end by saying that there's a couple more slides. One of them is to show that quantum mechanics is more complicated than I've showed. I showed 3 discrete degrees, but just to give you a flavor for what might happen, there are actually 2 sets of triplets. So this is the set that I showed earlier of energy, propensity wave, and actual effects. This is, I call, the actual degree. But if quantum field theory says that the energy has kinetic energy and potential energy, and quantum field theory says that kinetic energy comes from mass, which is constructed by virtual processes acting behind the scenes. And similarly, potential energy is not just fixed, but it comes from the exchange of photons or gluons. So that means that there's actually a similar layer, a similar set of triplet of degrees called the virtual degree. So there's the virtual principle that governs these, and there's virtual quantum fields and virtual events. And the virtual events act to to produce what goes into the energy operator here. So I'm not going to explain this in detail. All I want to say is that these discrete degrees are a useful way of understanding the more complicated structure that physics is already discovering about what happens in nature. So this is sort of what's called classical, ordinary quantum mechanics, this triplet. But these three above here is quantum field theory, which was invented at the end of the Second World War, and it's become the dominant way of looking at things. And it just gives you an idea of how things may yet become more complicated than we've shown so far. And so you have to have a rather general idea of degrees and discrete degrees. So what's important is the functional relation between different things, which I say should be thought of as discrete degrees, these generation and selection. So there are more complex structures of discrete degrees should be expected. And I end now by giving a little preview of next week's talk, which is about trying to understand theism. So I want to show that we need to form good concepts of God, which are not metaphorical or hidden from science. Last week I gave you a preview of what these principles were, but now it comes to drawing out the consequences of those principles. And in particular, we want to see how we derive our life from God. And because God is love and being and wisdom itself, but we love, we think we have some wisdom, we do things and some life. So the question is, how does our life derive from God's life itself? And I say, by generation and selection. These are the two principles which we need, which produce the discrete degrees that many people have talked about over the centuries. So I'm saying discrete degrees are the product of the principles of generation and selection acting in stages.